So we're going to go from 0 to CD in 60 seconds. CD is not compact disk, and it's not change directory. It's continuous deployment. Does anyone know what that is? Continuous deployment. 1, 2, 3, okay. Does anyone do continuous deployment? Okay, cool. How continuous? All the way into production? Okay, that's awesome. So about me, that's my email. If you want to get in touch with me, that's my Twitter handle. If you want to get in touch with me, I really appreciate that. I like getting feedback from people and finding out what people are wondering about. If you have questions, I have prizes for the first people asking reasonable questions. Not like, what color is my shirt, kind of thing. My everyday job is a CTO in a small law tech startup. I've been working as a consultant for 20 years, and that's enough about me. And we're off. So that's my presentation. Let's just scroll. I didn't even save it. Don't save. Screw it. So that's too small. So I have, what we're going to do today, hopefully, I realize I am the one between you guys and party. So that's fun. But we're going to take an app from basically nothing and get some tests on it, get some automatic builds on it, get some automatic deployment and some more tests and different types of tests, and talk a little bit about how we can get stuff into continuous deployment. Now, continuous deployment means when I check in code, it will automatically end up in production, preferably all the way. Who here has the rule that you do not deploy on Fridays? That is a sign that you're afraid of your own deployment. You don't trust it. You do not trust your own routines. You do not trust yourself. You don't trust your scripts. It's like you do not want to deploy or hit that button at 4:50 p.m. on Friday evening. It's like, yeah, it'll be fine. Don't worry about it. And that is a sign that there are flaws in your deployment strategies. There might not be your flaws. There'll be stuff that left behind that people came before you, and you're standing in the shit of giants, and you have to struggle with that. But in many cases, there are things we can do. So for y'all in the back who are actually paying attention, can you read sort of this? Okay. Oops. Let's go into code. This needs to be bigger. So here's a small little app. Let's just run it first. So squeeze this in. So we need an app to do this, and I'm really poor at typing at my laptop, so I'm not going to bore you with that. So I have a little thing to start off with. And it's the simplest, cheapest app in the world, whenever it loads. It's a small React single-page app. And I'll go through it in a little bit. Oh, this is nice. Compiled with warnings. There we go. I can press the plus and I increase the number, and I press the minus and I decrease the number. That's awesome. And if I go to 0, I can't go further down. That's my business logic. This is all in the file, basically the counter file. Let's hide this. So if you don't know React, don't worry about it. Here's some HTML. Here's a button. When I click it, I set the count to count -1. It's disabled when I cannot decrement. Here's another button. It's called plus. When I click it, I set the count to +1. and I have a little routine here saying I can decrement every time as long as count is more than 0. That is basically my app. Now, in order to trust our code and get things going automatically, we need tests. We got to have tests, and they have to be automated. So I'm going to talk about a little bit how we can test our front end. So this is a React app. I'm going to be talking, I'm going to be using technical examples, but the concepts are the same, whether you're using Angular, Aurelia, Vue, React, whatever on the front end. It's basically the same thing, just different names every now and again. So one of the tests I have is what's called a snapshot. It will take my component, use React to render that specific component, and build what's called a snapshot. I think I'm going to use this terminal instead. So let's run our tests. So the snapshot creates a file which is supposed to go into source code. It goes here in this snapshot file, and there's a representation of the HTML in your file. But it takes away all the things that are not content. So the autoclick is just, it's a function. This has to do so you can guarantee that the way your component looks doesn't change unexpectedly. Because when we're doing front-end development with different components, one component includes another component, another component, another component, and someone changes this thing down here, and then a whole bunch of other things suddenly change, and you didn't expect it. So we want these tests to show us that, oh, by the way, these things also changed now. You got to check that out. So those are useful. All my tests pass. Excellent. So if I were to go into my counter file and say, for instance, minus instead, save that, my test will run again, and I will probably hopefully get a warning. Inspect your code, one snapshot failed. I can just press U to update it if I'm expecting a snapshot to fail. Because I made a change to one component, I would expect a snapshot to fail. If it says 43 snapshots failed, I have an issue. I got to check something out. So I'll remove that error and go back. Another thing which is common to do with front-end code is basically try to massage it the way a user would. So when you're doing component-driven development, which we often do now in the front ends with Angular and Vue and React and those, is that try to test your component as a user would use it. Test the external behavior and not so much the internal, go into the internals of it. That makes your test a lot more robust. So for instance, I can render my counter here. I can get by text, which is a function of something called React Testing Library, which says, get me something that has this text in it, minus, and get the disabled property and expect it to be defined. So I'm expecting that the minus button to be disabled when I just load my app. I'm expecting the plus button not to be disabled. And stuff like that. If I increment it, I can click an event, find the plus button, click it, and I expect the counter to be 1. I'm testing the external behavior as a user would see it. Okay. Here, yeah. So let's open a new terminal. So let's get this under source control. Oops, not init. Let's add all of this. I'm just adding my files here. NDC Counter. That looks weird, but we'll run with that. So now basically I'm checking it in. I'm creating a GitHub repository for this. And let's push it real good. And just set it up to track, GitHub to track my branch here. And we're good. So here's my counter on GitHub. It's public, so you can download it if you want. Okay, so what we want to do now is we want to get this build started right away. Automatic build, the CI, is the first line of defense. And you want to get that started as soon as possible, because the more you put into your project, the harder it is to get that going. So in interest of time, I'm going to cheat a bit. So here's a funny file, azure-pipelines.yaml. It's a Yambol file, which means white space is significant, which sucks, but we'll have to live with it. Significant white space could die in a fire, so far as I'm concerned, but okay. But who here was in the last session, the previous session? Okay, so nobody. That's cool, because he went through a bunch of these things as well, but on a different angle. So the YAML file is, so a build is comprised, any build, whatever product you're using, a build is several steps. Do this, do this, do this, do this, more or less. In Azure DevOps, which I'm used to, why I'm using here, we used to have a graphical interface to set this up. And they changed this to YAML files. Now that's actually a good thing, because that means your build script can go into source control. And you can keep track of what happens to it. So when people make changes, you know that people make changes, and you know what they did. So what we're doing here is I'm running a command. Yarn runs a script, test.:ci. Which is a script in my package.json file, test::ci, which runs the test and adds some stuff around coverage and reporting. Those are a couple of, we'll see the effect of that in a little bit, but we won't go dive into it. It runs a build, yarn build, which will build my app, and in a publishable fashion. It will take all the files, will combine all the HTML, it needs all the JavaScript, minify it, and do all the things it needs to do to make a production-ready app, and put it in a folder. I will publish my test results, because they will show up in my build. I will publish my code coverage, because they will show up. And then I will publish my build artifacts. Now, every build has an output. In a build, you do a lot of stuff, and at the end, you'll get some output. Those are your artifacts. Those are files that are the result of your build, and they will go on to do other great things. So I'm publishing the path build and the artifact name counter. Okay, now we got that in here. Let's add the build script into Git and push it. Oops, that's not where I wanted to go. Here we go. we'll just sign in to Azure DevOps. The passwords are for suckers. Yes, they signed in. Okay. So here's a little project I've made earlier. Azure DevOps has a bunch of stuff. It has repositories, it has work item tracking. Who has used Azure DevOps or TFS or VSTS in some case? But one of the things it has pipelines, which are build scripts, basically. So let's set up a new pipeline. We'll pull it from GitHub. We need to zoom this in a little bit. There you go. If you can't see in the back, come further up. So we'll pull it from GitHub, sign into GitHub. There we go. GitHub doesn't have passwordless authentication yet. So we'll have to log in there. And NDC counter is my project. It will find that, okay, you have a pipeline Yambol file, so we'll just pick that up and say, here's your pipeline. I can edit it if I want, or I can just go run it. Now that kicks off a build. And while that's doing that, we'll look at a little other thing in my Yambol file. So on top here in my Yambol file, I have trigger master. That tells Azure DevOps to watch the master branch of my GitHub repository. It will set up a webhook with GitHub. So whenever my master branch is updated, Azure DevOps is notified via webhook and will go pull the source and kick off a build. So here's this thing off. Now, I'm using the hosted build agent because that's just easy. If you want faster builds, set up your own build agent because then you won't have to do an npm install every single time. But that will just carry along pleasantly. So if my tests are bad, the build will fail. I will get notified. Usually you'll get notified by email. If you're clever and a bit of a maker in you, you'll set up alarms and blinking lights whenever your build fails, which is always nice. I had one project, we had this huge red light in the ceiling. So now when the build broke, it would just start blinking red. All over was like, okay, who did it? The CI is your first line of defense. It protects you from your own mistakes, but it protects you from other people's mistakes as well. Because someone will do something, they haven't checked in a file, they're using something locally, then they're shipping it off, and suddenly nobody can work, and they've gone off. And luckily this worked. I can see a summary of my stuff. And here's the published tests report. This comes up here. I can see a little overview of my tests. How many have passed, how many have failed. This is awesome. I get 100% pass on all my tests. I can also see code coverage to see how much of my code is actually being tested. Am I lying to myself by having lots of tests, but I'm just testing the same thing over again? So only a small part of my application is actually tested. So how am I doing so far? I got 100% line coverage, which isn't hard when you have this kind of app. It gets harder after a while. Obtaining 100, keeping 100%, it's not realistic. You'll never do that, and you'll spend a lot of time tweaking little, I want to get that last little thing there. And sometimes you just got to go, okay, screw it. I'm doing something else. But you can go in and you can see what lines you're hitting. Okay, all of these lines have been hit, and you can see which lines you don't hit. And sometimes it's good to go in and say, okay, is this an important line? Am I missing some logic here? my rule of thumb is that if you have an if statement, you test it. Because that is a place where your code can go two ways. And you should test both paths. But there's no rule without exception. Now, so this is nice. Now over here, I have the artifacts button, which I have two artifacts. One is the code coverage, it publishes that. The other is the counter, which is the files that my build produced. Now, let's make a release out of this. I can just click here, go to release. I get a lot of choices on my right-hand side here with different templates. I can start with an empty job. I'll cheat a bit, and I'll start with an Azure App Service deployment and apply that. So what we have here is on my left, I have my artifacts, which is my build. That's where they came from. So I can say, I can get different versions. I can take the latest. It's usually the one I want. I can set up an alias for it, which makes it a bit easier to reason about later. This is my counter. I can say that this is enabled. So every time a new build is available, the artifacts part of my release pipeline will light up and say, new files. I can also say that I will only do this on master or default branch, which is useful. I can have CI go on all the branches, and I can have the release only trigger on some of them. I can also have releases that trigger on pull requests. So you can set up, every time someone does a pull request, you get a deployment somewhere, so you can test that out. We're not doing anything of that right now. So my trigger for the next stage, this is like a flow chart, so are triggered every step. So the trigger for the next stage is after release. I can do some filters here. I can do approvals and all kinds of stuff. But I don't want approvals. I don't want people messing with my deployment because people can't be trusted and they have vacations and shit. So I'm going to deploy this one straight away. Now, this is deployed to Azure App Service, so I'm going to have to give it some information. The information here is not really important, and that's not what I'm trying to teach you. I just have to do this to make it work. The point is you can just set it up. I'm going to deploy this to NDC MN Dev. I cheated. I created a little Azure environment beforehand, so you wouldn't have to sit around and wait for that. I'll call this stage Dev. And if we go down to, this part, those come in here, and that's. Now, I do not want to have the default here, which is just for a .NET Core app, but I'm going to pick from my artifacts that are linked in, the counter artifact. This is the folder I want to deploy. There we go. And that's pretty much it. Yeah, I can set it up to not download the code coverage report artifact because I don't need that for my build. So that makes my build a couple of seconds faster. I can also choose what kind of machine I want to run my deployment on. Right now it's running on a hosted Windows machine with VS 2017 on it. I can run it on Ubuntu, Windows 2019, Mac, or I can have my own agents. I'll just go with the default here. Nice. Okay, let's save that. And since I'm not pushing anything yet, I'll just manually create a release. It's always nice to have one started to make sure it works. Let's create that. So now the release is started. So my pipeline here, I go to my release. So now my manually triggered, release is going on here. It's going to the first stage. It's in progress. I can go see the logs. It'll hook me up to the agent. And it will hopefully deploy stuff to where I want it. And it all worked nicely. I go into the logs here. There's the URL for my app. I can open that in a new window, and here's my thing running in the cloud. You're welcome to test it out if you want. Okay, nice. So there we go. Now, if I make any changes now, it'll be checked in, and it should just work. But, so that's the front end. Let's have a back end as well. It just so happens that I have one lying around. Let's go to Visual Studio and do this. So that should be the same location. Still it wasn't. For some reason, my Explorer window is always slow. Does anyone else have that problem? Here, there's my API. We'll just open that there then. Of course, do not open it in the one I already had open. That would have been stupid. So I need an API for my counter because I want to save this for some obscure reason. And Visual Studio went away. Great. We'll try again. Third time's the charm. And this, again, this is a really stupid API because the business logic in the app is not the point. But it's a point to show you a couple of different ways we do testing. We don't need that. Okay. So my app has a single controller. It's called the Sessions controller, where I can send a post and get a new session ID back. I can put a value to my session. So I can say the value of this session is now 42. And I can get the value for a session back. That's basically it. I'm using ASP.NET Core Web API here, so I'm using the dependency injection that comes with it. So my controller gets a session service delivered to itself, which it will use to do create and all those nice little things. And my session service gets a configuration from dependency injection again. It gets a connection string for database. Here I'm using Dapper, simple database. Queries, select something, query it, return it. There's zero error handling here, so do not use this as an example of how to make your application at all. If you do, you will have a bad time. But the interesting part here is how can we test this, and in different ways of testing this. So I have a little piece of logic. We'll start with that. Saying that if my session, if you're asking for a session that doesn't exist, I should just return not found. HTTP code 404 saying to the client, I can't find what you're looking for. Now this is a little piece of logic that I can test just that thing specifically. And since I'm using dependency injection, I can test that piece without involving the rest of my application. I don't have to involve the servers. I can fake it. So I have here a little thing that sets up a mock, which is, if you're into this stuff, you have people debating the difference between fakes, stubs, and mocks. If you're not into it, it's a mock. It's a thing that mocks something else. It just fakes something. It pretends to be something it isn't. But I could do stuff like saying, when you're calling the get function with any it doesn't matter which one, you should return a session type with a null value. So basically saying, pretend to be this thing, and if somebody calls this function, give them null back, which in my service is the result you would get if you tried to ask for something that didn't exist. And then I can just instantiate my controller with and inject my mock and call the function. And I can then assert that my result should be of type not found result, which is the type result that the web API returns when you say not found. So we'll have to build this so we can discover some tests. Here's my test unit. Here's my session controller test. Up in the corner here. So now I can try and run this, and hopefully that works. Now this will run without anything else. It will just run that particular piece of code. But it is sometimes interesting to have tests that test a more vertical slice of my application, which are what we often call integration tests. And I have some of those as well. Oops, not there, but here. So here's where I can stand up. An ASP.NET MVC, ASP.NET Core has a little thing where I can, it has what's called a web application factory, where I can say, stand up a web application without actually setting up a web application, and give me an HTTP client that can call this web application that isn't really a web application. But what it does is that it allows me to test my web application from all the way to from the edge of it, through filters and middleware and all kinds of things, all the way into the actual controller and all the way down to the database if we want to, and back again. Now, here I'm not doing much, but the factory here allows me to create client, which will return an HTTP client. And I can do stuff like post async. It doesn't actually do network calls, but the whole pipeline is activated as it did. So I can post to sessions. I can assure that I get a success code back. I can say that whatever I got back was a digit. Now, in order to do this, I need a database. And I happen to have one locally here. And I've set it up with my app settings, local DB, integrated security, true. And that's what it is. So if I run those tests, it will actually hit that little database. Now, integration tests are slower. They're harder to deal with because you have the external dependencies, but they can be very useful to test a whole bunch of your app in one go. And you want to test those parts as well. You don't want, yes, question?
Just a quick question. You have those databases there. When you move to the build server, do you have to have a SQL server on the build server?
Yes and no. I'll get to that. The question was, do I need a SQL server on the build server? Maybe, maybe not. You can if you want to, but you don't have to. So, right. What I do with the database. So where does that come from? Now, we can use ND Framework, we can set it up, use those things. I like to use what's called the SQL project in Visual Studio. Anyone else ever used the SQL database project in Visual Studio? Okay, 1, 2, 3. Where you can write your SQL, and it will automatically figure out what do I need to do to go from where that database is to where it should be. And we'll figure out those the migration step and execute that. The good thing about this is, so Entity Framework is nice. I like code first. It has a lot of advantages, but it gets very complex every now and again, and then you get into the more advanced SQL stuff where you're going to have some indexes here and some stuff there, and then you have some stored procedures to make some things faster, and then you have some So you want to sometimes keep your database in source control as text. This database project will do that. It has a couple of other advantages as well. And it can create what's called a DAC pack, which I can never remember what actually stands for, but it's basically your information about your database in a single file. And it can use that to deploy with. We'll look at that a little bit later. So if my SQL is wrong, the test will fail. So for instance, if I go into my session service and I go insert into sessions and I run my tests, at least one of them should fail, hopefully. They all failed. Okay, let's fix that. Great. Now let's get this thing as well. Okay. So let's get this thing in the cloud as well. So there's my, let's add an existing item, get that up here, my Azure pipelines. So this one runs, again, triggers on master, runs on a different kind of image. The other one ran on Ubuntu. This one runs on Windows 2019 with Visual Studio 2019. My build configuration is release. Now, I'll get to that later. I have a script, .NET Publish. We'll just create a publish package of my application. I will run my tests. The SQL project I have to build with not .NET, I have to build it with VS Build, which is why I'm running it on a Windows machine. I can publish my test results, and I can publish my build artifacts, DB and test artifacts. So let's get this guy on the road as well. Not as, but add. NDC API. NDC underscore API. So that will create my GitHub repo. Push that up. And open it up. So there's my repo. Now let's go to take a trip down to my builds again here. New build pipeline from GitHub. The NDC API. Build pipeline is fine, I hope. And it runs. Now, this will probably fail for the exact reason that gentleman down here mentioned, because it will try to run my tests, but it will try to run them against my local database, which is kind of iffy. Now, I could actually, this is a machine with VS 2019 installed, so I could run SQL local DB and just create a local DB on it. I can do whatever I need to do to push some data into it. So there, my unit tests failed. Oh, That failed for a different reason. Let me see, am I got a dependency on that? Yes, I do. My unit test project had a reference to my database project, and they don't like each other. So I'll have to just remove that. So Git YOLO is a PowerShell like this that pulls the text from what the commit and just uses that. So that was completed with no bugs. Just takes a random commit message and uses that. So that got pushed. Let's go back to my builds. Completed with no bugs, hopefully. So that kicked off automatically now, because I pushed it, and it started building on its own. I didn't have to kick that off on it manually. So let's see if this should run as... It'll still fail, but it'll fail for a different reason. It'll fail for the proper reason this time. So it will fail because it's not trying to use, it should fail, because it's trying to use the local database, which doesn't exist. But we can override that by, here we go. Now it just stood up this is just for standing up the web host. Some messages coming in saying that it's ready and to take orders, and it will hang a little bit because it's going to time out. The thing that will fix it, here we go, lots of errors. Everything failed. Failed, cannot find, timeout period elapsed, and so on and so forth. Crashes spectacularly. So, let me go into, so I happen to have a SQL server in Azure. So I'm just going to use the dev database for this. And the reason I want to use that is because that is the database. So when you're doing continuous deployment with databases, you have to do things in a staged fashion. If you're changing your database, you should first push a non-destructive change to the database. Only add stuff to it. And then when when that's working, then you can change the code to react to the new part of the database and do whatever you have to do to make sure you can live with both the old and new at the same time. And when all the code is in, using the new part of the database, then you can push the changes that removes stuff from the database. Because the database and your application will be deployed at different times. Not necessarily a long different time, but there will be differences, and you don't want to lose that, have people have errors in between. So what I want to make sure is that every code that goes in can use the database that is actually in existence right now. So I'm just going to nick the connection string here. With my super secret password. And app settings has my connection string, default connection, here we go. Connection strings, default connection, and I can substitute stuff. That was the part I skipped in the pipelines. So I have a file transform here that will go through every JSON file, and it will look up. So we'll go to my build. That's the API. Let's edit that. And even though I have my pipeline YAML here, I can go into variables. And if I set up a variable that will add connection strings dot default connection, it will find, it will look in those JSON files. Let's make it a secret so you can't read it. It will look at those JSON files for something, connection string property with a default connection underneath it, and it will replace that value. So let's just save and queue this one. Now, hopefully, my job will replace that text in the app settings file, pointing it towards the database in Azure, and my script, my test will now run, massaging those features, and it will actually call the SQL database. Fortune favors the bold. Let's see how this works. There's the web host starting, and yeah, everything went fine. Total tests, whoa. Total test 4, passed 4. So I'm happy with that. So that ensures me that every code that's going in now will work with the database I already have. So it won't break that part. Okay, so let me see. I got a little notes here, make sure I don't skip any part and make it hard for me after a while. Okay, so let's get this one out into the wild. So here's my API. Again, here I have some artifacts. I have the API, you have some tests, I have the database. Let's just release this one. I'm just going to deploy this one to a web app as well. Call this stage dev again, because I have no imagination. So here we have to set this up as well with the Azure settings, subscription, which web app do I want to deploy to. Now, this whole experience here will, in the next few days, they'll start rolling out that you can use YAML files for this, for the release pipelines as well, and not just the build pipelines. So then it's YAML all over the place, whether you like it or not. You can opt in with the previews pretty soon, I think. So that's that. The agent, we've done that. And then let's go back to the pipeline, and we'll add a second stage, empty job. Now this should not, so I can have a stage that triggers after another stage, but I'm going to take this and trigger after release. And I'm going to say this is DB dev, and I'm going to say that this is the API dev. So I can do now parallel jobs if I have enough agents. So here we'll do the data Azure SQL database deployment, the DACPAC task. Again, it needs a subscription. We're going to hook up to a SQL server, which is ND, I can never remember it. Do I have the connection string still? Oh, it's here. Anyway. There we go. Oh, I didn't want all of that, but okay, that's cool. SQLMN dev database was NDCMN. My login is NDC. My password Now, I don't want to keep that kind of stuff laying around here, so I'm going to do dollar parentheses SQL password, which means that take this from a variable instead. We'll publish this. We can do a lot of other things with this task. DACPAC file, we got to find that. That comes from the artifacts, the DB artifact, the DB DACPAC artifact, okay. We don't need to add a profile. This will, if you have a firewall, it will auto-detect the firewall and set rules to open it up, and then remove those rules afterwards. So yeah, there's that. For the API dev, I don't think I remember to set which folders we want. So we're gonna go here, the API. This is the stuff I want to deploy. And here you can also do transformations if I want to do that, which you might want to do if you have different environments. I think I have everything. So it's not really important to know which values I'm using where. The most important thing for you guys to know, or you people to know, is to know that this thing actually exists. So let's try to create a release here. So yeah, let's create that. Release 1 has been created. So now this will run hopefully in parallel. And I'll have a little API with database connected to it. Now, let's go back to our counter. And we're going to upgrade this a bit. So now I had some changes happen. Let's see, did they show up here? Nope. So am I running failed compile? Can't resolve access. Oh yeah. We have to do yarn to install a dependency. So now I've upgraded my counter to use the backend. So let me just run this one locally first. Is there a movie theater in here or somewhere? They had lots better speakers than I had in this room. Oh, yeah. Oh, wrong folder. So here we go. Here's my local host. And let's take a look at what files we changed. So I added a session component. Now, I added a session component which basically just has a button that says start new session. And then it will, when you click it, it will start session, which calls a post to API sessions, gets a response, and sets that value, and feeds that thing further into the counter, and it doesn't show the counter unless you actually have a session. So if we go here, it says start new session. If I click it, I am now on session 2002. And I can up my little values, and every time I do this, some gnome in my machine has to shuffle this over to the back end. If I go look at this, I can see, okay, here's a bunch of results it's actually stuff is happening there. Now, the only thing I had to change in my test, so what I did, I just wrapped my counter component in a session component and fed some data in. So the only thing I had to change in my tests is to, this was nicely to see. Let me see if we can go this in. I had to add the config attribute to my component in a couple of places. But all the logic in the test stayed exactly the same because I didn't change the behavior of my component. I did a whole bunch of things inside it. So my counter component got a lot of work done with it. I moved it to its new functions. They're now calling backend through Axios here, calling the API. All that stuff happened inside the component, but because my test the external behavior, my test basically worked. I had to add a little thing of passing some data into it, and it's fine. I could have gotten away with that as well if I'd mocked that away, but I didn't. Okay. Apart from that, nothing really much happened. I'm getting a config file from, which has the base URL, so I can swap this between here and in production. And what else is here? Oh, something not added. These guys are flipped. So let's push that. Now that's pushed to the Azure DevOps. It will go off, do its tests, which hopefully will work. I did the cardinal sin of not running tests locally before I push. So hopefully that will work. There's tricks you can do with that as well. You can set up commit hooks and GitHub anything. Now, I'm actually out of time, but I wanted to do a little thing. So if you want to leave and go to the party, I totally understand. I won't hold against you, no judgment. But I want to do end-to-end testing with UI tests first. I want to finish off with that. So let's do this. Let's see what happened. Did I get the right files here? Yes. So what I'm using here, so UI testing is standing up a browser and manipulating the browser to click around and fill out stuff in your browser, which is automating what people will do poorly. People will do it poorly, it's not poorly automated. Because you say, oh, well, can you go in and test that feature? And they'll go in and they'll click a little bit about and they'll, okay, it looks fine. And then the next time, can you go in and test the new release? And they'll go in and they'll test whatever new, but they will never go back and test what they've tested before, which is probably the thing you broke and didn't know about. I mean, if you broke the thing you just made, you'll probably figure it out. Because you're going to test, you're going to try, but you will not discover that you broke the thing you made 6 months ago because it changed something that has a commonality somewhere. And that is what UI tests will do. They will break on old stuff. Oh, yeah. So, turns out, Yarn and the watcher of Jest, they do not play well together. If one is running, when you run the other, it's just all kinds of errors appearing. So on here there's all kinds of different ways you can do this. You have Selenium, you have WebDriver, you have the old coded UI test, Visual Studio. Anyone ever use those? Those have been deprecated, so don't use them anymore. I'm using something called Test Cafe. So in my package.json again, I have a Test Cafe part there, and I have a little script that will run Test Cafe for me. So here we go. So let's go in here. I have a folder called end-to-end. And what we have in end-to-end is that I have a little file that basically says, start on this page, open it up, click that button, expect that spans inner text to have 0. There's a little bit like the other part we were looking at, but that tested just the component in isolation. This will actually manipulate the whole web page and do the whole full shebang from the front end, across the wire to the back end, and across the wire to the database, and all the way back again. I can open the page, increment, decrement, and do all kinds of little stuff there. So if I run this locally, let's run it in Chrome. So then it will run, and it opens up my web page, and everything failed. Nice. Okay, cool. Maybe my deploy failed. Anyway, that went. The counter should be deployed. Oh well, screw it. I'm out of time, don't have time to fix it. But what you can do with this kind of stuff is that you can set up all of these kinds of tests. Unit tests on your front end, unit tests on your back end, snapshot tests, integration tests, UI tests, and use those as gates to allow your stuff to go on. And then, when you get even further in, you can have multiple environments, and you can have measurements. You can deploy to a small part of your customers. You can say, okay, put this here and shift 10% of my traffic over there, and monitor for exceptions. If I get exceptions, then roll back. All these kinds of things. Now, we've got this running. It's up and running. One thing doesn't work. I don't know why, but we'll figure it out eventually. We can do that. That's a party. But we now have a system which will deploy a front end, deploy a back end, and run different levels of tests, from unit tests, front end tests, back end tests, integration tests, all the way up to UI tests, before it actually gets to release. Which gives you a lot more confidence in that whatever goes out actually works. And you can do, a guy I talked to recently, he deployed a new version of their software on the train home from his phone on Friday. So that's how confident he was in their system. So we can all aspire to get to that point. If anyone has any questions, then feel free to holler out. I'm 6 minutes over time already, so